The bottom line is the industry seems to be looking towards composites as a viable solution to many of its problems. So the first question, is the industry ready to accept composite materials in subsea production applications? 72% said yes, 28% said no. Okay, so that is a major shift for the industry. Partly maybe driven by the challenges, partly driven by the requirements to reduce cost, but the industry seems more ready to accept composites today. Why is that? So I think it's as a result of two things that have really come together in time. So we have increasing industry challenges, as I mentioned, corrosion, fatigue, weight, and that's starting to ripple through in terms of increased risk around the projects, and obviously in terms of increased costs. And it's not just as a result of pushing deeper and higher pressures and sour service, etc., which we're seeing more and more of going forward. But these are just general industry challenges. And that alone isn't enough, but it happens to have coincided with a composite technology which has been matured in other industries. So 10 years ago, Magma couldn't exist. So it couldn't exist. I think the materials were pretty much there 10 years ago. The technology required to manufacture this was not at a level, both from the point of view of its sophistication and reliability, but also from the point of view of its cost. It was not at a level which would make commercial sense. Okay, so this technology has matured. It's matured in a number of industries. I think most significantly for oil and gas, it's matured in aerospace. So a very safety critical application. Okay, so pretty much every single aircraft you step on today, any commercial passenger aircraft, it stays in the air because of composites, okay, in some way, shape or form. So if you look at the 787, where you flew United, 787 from Houston, okay, great plane, okay, composite fuselage, composite wings, fully composite, okay, carbon fiber plane. But even if you jump on an A320, you'll find the wing spar of the A320, the A380, I think the 50 and the 40 as well, are all composite wing spars. Yeah, invariably the tail planes have been made from composite for many, many years. So the aerospace industry really has spent the last 30 years working at both the material science, ensuring that they have the analysis tools effectively to predict performance, and we're seeing the benefits. And the driver for aerospace is great. Okay, because it's, you have to be concerned about weight. So composites not only give you the strength and the fatigue capability, but they give you the reduction in weight. So big win in aerospace. The other one that's interesting is civil. So in civil, weight's not so much of an issue, a little bit like oil and gas, where you've been less concerned about weight historically. But why are civil actually running after this? So weight is an issue, bridge constructions, etc. It helps. Okay, but purely the performance, reliability, the fatigue performance of composites now sees increasing use of carbon fiber and composites in bridges, in large structures, in large architectural structures. The two biggest composite projects ever in the world today are civil projects. One is the bridging system in Mecca, which I believe no Westerner will ever get to see. Okay, that is actually the world's largest use of carbon fiber ever. The second is a bridge in Australia, second largest use of carbon fiber ever. Okay, the third largest project ever in the world with carbon fiber was the mast that we delivered in the middle of the year. Okay, so it's definitely the technology has matured within these industries, and that maturity really has covered three areas. So maturity in terms of materials. So today the materials that we're using have been extremely well matured within aerospace. So both the carbon fiber we use, industrial grade carbon fiber, T700, and the PEEK that we use are both fully qualified within aerospace and used extensively within aerospace, as they are within other industries. The automated manufacturing technology. So the aerospace industry really pioneered the use of robots to build composite structures, and they needed to do that because of two things. They needed the reliability and consistency to give them the quality, and also they needed the cost reduction by taking people out of that process. So the same sort of drivers we have. And that's also resulted in a maturing of the analysis tools. And that's obviously critical as well for us. So what are we all about then? I mean, I think as you all know, M-pipe, we say is a high quality, high strength, cost effective pipe. Our two main suppliers, Victrex for the polymer. Again, we're locked into one supplier. There are different peaks out there. Victrex peak is attractive to us because it's already established within the industry and used fairly extensively with hydrocarbons. Torre, the world's largest provider of carbon fibre, provide all the carbon fibre for Airbus and Boeing for their major structures. So it's a very well qualified product. We also use something called S2 glass, which we'll touch on during the day, I'm sure, and that is a high-end glass fibre that we use in certain aspects of our product. So material selection has been key to us, and as I said earlier, we're locked into those materials, and we will stay with those materials to enable us to qualify properly. We have a fully automated 3D laser printing process, which you're going to see as you go around, so I won't say too much about that. And finally, a well-engineered oil-filled standard end termination